Welcome to the training video, The Art of Reading a Building. I'm John Mittendorf.
And I'm Dave Dotson.
Hopefully this video will give you a practical opportunity to use the information in the book, The Art of Reading a Building.
And we're going to do this by offering a series of video examples that allow you to practice that skill set. We're going to show you building after building and offer you the opportunity to make a read on that building. Are you ready to get started? The starting place for reading a building is taking visual clues and trying to understand how that building was built. After all, how it's built tells you pretty much how it's going to fall apart when it catches on fire. Now, typically the fire service has classified buildings as one of 5 types, like type 1, 2, 3, 4, and 5, and each one of those means a certain thing. That is a gross oversimplification. The smart fire officer looks at a building and classifies it based on kind of 4 influencing inputs. Not only is it type of construction, as outlined in an NFPA 220 system, but also the era or the vintage, the time period in North America when it was built. But we also have to look at what is the building being used for. Not necessarily what is it currently being used for, but what was it built to be used for. And then we look at what is it currently being used for. In other words, what's its occupancy? And then lastly, we got to look at the building size. So it's that formula, type, era, use, size, that leads to a good read on the building and an understanding of how that building's going to perform. Now let's just start in a brief review about the types of construction. We know there's generally 5 types of construction. Type 1 being fire resistive, type 2 being non-combustible, type 3 being ordinary, which is kind of a generic term for a masonry built building with wood floors and roofs, right? Then we have type 4 heavy timber, and lastly type 5 wood frame. Now once again, that is way oversimplified for a fire officer in understanding a building, right? Because we know that there's buildings out there that don't fit any of the 5 types. Or it's kind of like a slang we call the type 6 building, or some people are calling it the hybrid building. And maybe right here, we can just define the hybrid or type 6 building. That's the type of building that doesn't fit any of the 5 types, or a building that is more than one of the 5 types built into the same building. So you can look at it either way. In any case, that's not official, the type 6 or the hybrid building. But once again, that's a starting place. Why? Because the era that it was built determines how they went about creating those 5 types of buildings. Now we know, looking back at the history of North America, that there's pretty much 4 distinct differences in the way buildings were built. The first, for lack of a better term, was the historical buildings. These are any buildings that are still standing today that were built before World War I. So that's like our first era classification. Now, because of a lot of mechanized discoveries in World War I, we changed building construction in America. And we led to the next era of construction. Let's just call that the industrial era. Some people call it the craftsman era, because there was a lot of craftsmanship that went into those buildings. But that industrial era, we kind of mega-sized all our buildings. And we discovered steel. Steel really changed the face of buildings in America. And then World War II hit. And as most of us know, World War II, there was a lot of rationing of materials. And part of that rationing led to economizing and engineering buildings in a better way. Use less material, made them stronger. After World War II, we had some good times in America. The expansion of America took place. And with it came maybe and arguably the most firefighter-friendly building out there. And that's the legacy constructed building. So anything after World War II up to current times is what we call the legacy building. And then sometime in the 80s or 90s, the codes changed, the building codes changed from a prescriptive code to a performance code. And with it became this onslaught of lightweight engineered construction. Or we just pick a name out of the hat, let's call it the millennial building. So we have 4 distinct eras of construction. historical, industrial, legacy, and the millennial, or engineered lightweight building. That's 2 of the 4 inputs. The next input is the use of the building. What is the building being used for? But we have to look at that with 2 realms. What was it originally intended to be used for, and what is it currently being used for? And that helps us provide clues as to fire protection features that might be required of the building, what kind of occupancy load in terms of numbers of people can you expect, maybe some general building geometry layout considerations, and certainly probably the most important part of use is what's that fire load and how is the building going to react to that fire load burning. Last on our formula, if you will, is the size of the building. The size of the building has to do with many different factors. And typically in the past, we've looked at a building and called it small, medium, or large. I think you'll agree that in today's world, there's more than just small, medium, or large. We now have our big box store, and we also have our mega box store, or like a huge covered mall that has multiple anchor stores in it, or a huge casino. We could call those mega boxes. And then of course there's that challenging, or firefighter challenging building that we call the high rise. Now maybe for discussion we can say that a high rise is any building over 7 floors tall, right? And the challenges they prevent or create for fire departments. So when we look at small, medium, or large, there might be, I'm just going to say, a street tool, a down and dirty rule of thumb to help you differentiate small, medium, and large. And John and I came up with this, and it's what we call the 2-4-6 principle. A 2 building is a small building, a 4 building is a moderate or medium-sized building, and a 6 building is a large building. So what does the 2-4-6 represent? Well, the 2 in a small building represents 2,000 square foot or less, 2 stories or less, 200 feet of hose will reach any part of the building, and 2 interior attack lines should be able to handle an interior fire. If you need more than 2, you probably should be outside. All right, so as you can see the pattern, what does a 4 represent? 4 stories or less, 4,000 square foot or less, 400 feet of hose can reach any part of the building, and 4 interior attack lines should be able to handle an interior attack. And obviously 6 means the same thing. 6 stories or less, hey, that's below a high rise. 6,000 square foot or less, actually that one has to be a bridge because it could be all the way up to a big box as a large building, and that's more than 6,000 square foot, but it's not as big as a big box, right? And 600 feet of hose should reach any part of the building, and 6 hand lines may be required for an interior work. If it's more than that, you probably should be exterior. So that's our formula. Look at the type, the era, the use, and the size of the building. And that's the pattern to classify the building. Now, after you classify a building, we have to look at, okay, what are the traps that come with that classification of building? And John's going to take you through that.
We just finished classifying a building. Now let's take a few minutes and look at the observable things that we look at a building in what's just called a general size up considerations. Now we cover a lot of different angles in the book, but let me just cover some of the highlights of that. And I think first of all, probably at the head of the list would be familiarity with a building. There's nothing that replaces your familiarity with the buildings in your district. When you're out on runs, when you're inside of buildings, residential, commercial, you take time to look at how it's laid out, how you would do a search, how the floor plan would affect you. It is essential in some cases that when you pull up in front of a building to be familiar with what's common to your area. And what's really nice is when you pull up in front of a building, you're thinking, ah, I've been here before, I know this building. Now let's talk about 180-360 size up. 180-360 size up basically means when you first get there, it's nice to be able to do a 360 completely around a building. Sometimes we can't do that. Buildings on either side, maybe it's a large building, we can't get to the back. So it's important to see as many sides of the building as possible initially, but don't forget to do, or at least know, what you see totally around the building, and you might need to rely on other companies for that. Sometimes what you see from the front is not what you see from the back of the building. Let's talk about building status. For risk assessment perspectives, you can look at a building from 4 status viewpoints: occupied, unoccupied, vacant, abandoned. Let's talk about occupied first. Let's say you pull up to a single-family dwelling and you have a car in the front. Is it occupied? You're probably thinking, most likely. Right. How about you pull up in front of a single family at noon? No cars in front. Is it occupied or unoccupied? You're probably thinking, 50-50. You're right. How about vacant? Let's say that I have a vacant building that is boarded up and it's secure. Is anybody inside? If it's hard for us to get inside, it's hard for anybody else to get inside. So most likely there's nobody inside. Lastly, abandoned. Now here's the tough one. Abandoned buildings are usually in a state of disrepair. So is anybody inside? Is the building secure? Probably not. Is the building unsecure? Then there might be somebody inside. And that's your decision to whether you're going to go inside or not. Let's cover another angle on size up. Access egress. And I think this one in some cases can be very, very important in that all buildings are not built the same. And the key point here is it easy to get in the building? Is it also easy to get outside the building? And buildings that have minimal windows, minimal doors, concrete tilt-up is a classic example. You probably have a man door and you probably have an overhead loading door. That's it. And thousands of square feet of storage inside. That building is easy to get into, but it's not so easy to get out of in case you need to fairly quickly. Let's talk about another chapter in the book that we introduced, the concept of base of operations. Base of operations is defined as, what are you working on? Usually when you go into a single family dwelling, as an example, you walk in on the grade floor. Are you on a slab? That's good. Are you standing over a basement? Is there fire in the basement? That's not very good. You're on the second floor of a multi-story building. You're assigned to search. Fire is on the first floor. Is the second floor strong enough to support your weight in your operation? And lastly, roof operations. You're standing on a roof. Is fire in the attic or not? If fire is not in the attic, your base of operations is fine. If fire is in the attic, then are you standing on conventional or lightweight? It's a time factor. Conventional is going to give you far more time than lightweight is going to give you. So while we're on the subject of time, let's talk about time for a minute. Dave and I classify fire ground clock from 2 perspectives. There's all the elements before you get there. The time it was burning, somebody saw it, they turned it in, the time you're dispatched. Okay, that's pretty much of a standard, but the clock is running. But then when you get the alarm, you pull out of the station, down the street, you pull up in front of the structure, you get off the rig, you pull off your pre-connect, you go in the front door, you find a fire, you pull the nozzle back. At that point, ask yourself, how much time has elapsed? 3, 4, 5 minutes? What is the national average of collapse when fire exposes lightweight construction? Answer, about 5 minutes. So if you pull up to a fire and you have fire in the attic of a building, and maybe it was burning before you got there, and now it's going to take you 3 or 4 minutes to get inside to start to knock it down. Do you see where I'm going? You're already on the razor's edge. So I think one of the key elements when you talk about clock is a company officer or an incident commander. You know what is burning and where is the fire. Is the fire burning lightweight? Is it burning conventional construction? Let's talk about green considerations just for a minute. Green considerations have had a major impact on building construction. Insulation, double pane windows, cool roofs. What does that all add up to? It holds the heat into a structure easier, and what happens is your rate of heat increase inside of a structure happens a lot faster. Flashover happens a lot faster. 2x4 construction, you're starting to see 2x4 spaced on 24-inch centers instead of 16-inch centers. So we're using less wood. Wood is also poised right now to take the place of steel and concrete. So there's a lot of changes in building construction that again go back to that fire ground clock. We're having less and less time from the perspective of building construction. Lastly, let's cover 2 more elements. Facades. How many buildings in your district have a facade around the outside of the building? Probably a lot of them. What is a facade? A facade is a common exterior, common attic around the outside of the building, usually 3 sides, not the back. So when I come up to a building, what's our normal port of entrance? It's the front door. So if I have a section of construction overhead that is burning, if I know or suspect that, I should be very concerned about using that door as my access egress point. At that point, Dave and I would suggest think about going around to the back of the building, which we normally don't do, but yet if a facade is not back there, it can be a lot safer point of your entry and exit into and out of the building. And lastly, name on the building and utilities. Is there a difference between a building that says fireworks or a building that says Ben's Barbershop? You bet. In a lot of cases, commercial buildings, the name on the outside gives you a good idea of what you can expect to find inside. Same with utilities. Commercial building, standard residential gas meter. Okay, pretty standard. How about multiple commercial grade gas meters? Oh, now I have a process that is significantly different. As an overview, these are some of the factors that you should be looking at before you commit yourself inside of a building. Now that we've briefly overviewed the general classification of buildings and size-up considerations, let's go to the second part of this program.
In the second part of the program, what we'd like to do is sets and reps. See, the key to reading a building quickly at 2 o'clock in the morning at your next structure fire is in your unconscious competent ability to read a building. And the path to unconscious competence is repetition. Therefore, we're going to start you on sets and reps. Practice, practice, practice. Let's start with our first scenario. Okay, now it's sets and reps time. This is your opportunity to take not only what you've learned from the book, but what you've learned from our DVD here. It's actually pretty simple. We're going to show you a camera walk around of a building. Then you're going to see a pause sign pop up on the video. And then after that, you'll see some prompts. And these are just simple questions. What did you see? What is your read? Then when you've answered that either individually or with your group, you can hit go again on the DVD. And from there, you'll see an interpretation by Chief Mittendorf and myself, and you get to compare what you just saw and said. And from there, hopefully, we can learn to read about our buildings much better. Now, just as an example, John and I did this for a group in Tulsa. A bunch of Tulsa fire officers came together, right? And we did exactly what we said we're going to do for the scenarios here. So here's an example of how John and I ran this sets and reps exercise. We're going to show you a walk around of the building, right? We want to mentally log its type, era, use, size, right? And feel comfortable to talk about it and feel comfortable to discover errors. We can do that. But more importantly, we're going to ask you about strengths and weaknesses of the building from a firefighting perspective. So here you go. This would be your A, B corner, Alpha Bravo. Now we're walking Bravo side. Approaching Bravo Charlie. Side Charlie, your back of your building. We're not quite to side D yet. And a look down side D. Coming back up to side A, so this is your AD corner. And a nice view of side A. Okay, now we got a good 360 of this building. Now let's just start with how you're kind of envisioning. What's kind of the host of your party here? Anybody want to tackle type?
I would just say it was a type 3.
Type 3, what do you see that causes you to believe that?
Just the unreinforced masonry walls. Then you've got the bay windows, which kind of puts it in that era.
Okay, so our load-bearing walls on the side, right? And kind of your window configuration?
2-story, kind of the, what do they call it, historical small town America buildings.
Main Street USA.
Main
kind of
Street
stuff,
USA, yes.
Right? Beautiful, well done. Anybody want to take that era though? You want to just take the era since you kind of alluded to it?
I would assume it would be historical, based off the bay windows, the bricks. The only thing that throws you off a little bit is the D. David side being a bank there, but it looks like maybe there was a whole row of buildings at one point. But as far as this building here, I would say.
Okay, let's go somebody else for use and size. Anybody want to tackle use and size? Back of the building. Use.
Yeah, residential / commercial. That's a taxpayer building, so you're probably gonna those look to be apartments above, above the business there. And size, I would say, in the 246. I'm gonna call it. It's right there on the border. It's right there on the border. So I'm gonna err on the side of caution and say 6.
That's outstanding. I think I would agree with you on that. Okay, so we've kind of packaged this building. We know our host. We know our host is a type 3 building. It's probably historical era. It's a mixed use right now. Businesses downstairs, potentially residential or dwelling space up above. Could it be offices? Okay, it could be, right? But it's got that classic taxpayer vibe to it of Main Street USA. And size would be large. Okay, now if we know kind of classified how our host is put together, we have to get to strengths and weaknesses and tactical concerns. All right, so what kind of visual things did you see on the outside of the building that could lead us to understand strengths? What are some of the strengths of that building from a firefighting operation point of view? There's got to be some. Go ahead.
Heavier construction, so your time to work and for interior.
Wait a minute, if it's heavy,
operations.
wouldn't it fall on us quicker?
Yeah, but
So why is heavy a good thing? You're right,
Well,
but why is it a good thing?
you don't have prefab trusses and stuff. You're going to have full dimension lumber, which is going to burn longer. So your time might go from 5 to 10 minutes to 15, 20 minutes.
You were so right. You're right on it. Right? So that's a high mass building, which buys us time. Beautiful. Well done. Right? What else is working in our favor here? Go ahead.
Most obvious access to all sides of the building for apparatus.
Ooh, I love that. Wraparound access for apparatus. Did we have wraparound access into the building? That could be arguable, right? right? Especially here on B wall, we have small window access up above,